You know, when you're on a commercial flight, cruising at 30,000 feet, you mostly trust the autopilot to do the heavy lifting, right?
Right, yeah, it's just highly efficient. I mean, it's doing math faster than any human ever could.
Exactly. And it's completely invisible to you in the cabin. But if a massive storm rolls in out of nowhere, or like an engine sputters, you definitely do not want that autopilot just giving up.
No, absolutely not.
You don't want it throwing its hands in the air and turning off. You want it to seamlessly hand control back to the human pilot. You want a safety net.
Yeah, in systems architecture, we call that graceful degradation.
Mm-hmm.
You want the system to step down to a safe baseline rather than experiencing just a total catastrophic failure.
Right. And that concept, the fail-safe, that invisible hand guiding the journey, that is exactly the high-stakes logic we are dealing with today in the world of customer experience AI.
It really is.
So, welcome to today's deep dive. If the autopilot fails in the air, you need the human pilot. Well, in the world of enterprise customer experience, if the AI bot fails, you lose the customer forever.
Yeah, and that costs real money.
Exactly. So today, we are dedicating this time to mastering the key technical concepts and assessment criteria for the GCX-AI-GPE exam.
It's a beast of an exam, honestly, but cracking it unlocks exactly how these multi-million-dollar platforms actually operate.
Absolutely.
We're going to be talking a lot about two main engines today, GPB, which is Genesys Predictive Engagement, and GPR, which is Genesys Predictive Routing.
Right. And for you listening, we are going to tear apart 10 actual practice questions, step by step. We're providing an item-by-item breakdown of all the options, A, B, C, and D, with full audio commentary.
Yeah, we really want to explain the problem-solving logic here.
Exactly. So you deeply understand why an option is right and exactly how the mechanisms work when an option is just dead wrong. So let's jump right in.
Let's do it.
Before we can trust AI with the customer experience, we really have to understand what happens when it hits a wall. Which brings us to question 1. I'll read the full text.
Go for it.
Okay, question 1. What occurs when predictive routing is unable to find a suitable agent match within the defined timeout period? And here are the 4 options. A, the interaction is immediately disconnected. B, the system automatically prompts the caller to leave a voicemail. C, the interaction is routed to the queue supervisor. D, the system reverts to the configured fallback routing method.
Okay, well, let's look at the mechanics of option A first. The interaction is immediately disconnected.
That sounds awful.
It's the ultimate customer experience nightmare. I mean, the AI was given, say, 30 seconds to find the perfect human agent. It couldn't find one, so it just hangs up.
Right, that's like a store employee saying, I don't know where the ketchup is, and then just walking out the front door.
Exactly. It violates the core rule of customer service.
Yeah.
The system would never be designed to drop a call just because the predictive model timed out.
Makes sense. So A is out.
Yeah. Now let's look at option B. The system automatically prompts the caller to leave a voicemail.
I mean, that sounds plausible, right?
It does, but mechanically, it's a rigid, forced action. The system assumes voicemail is the desired outcome without checking the queue depth or, the business rules. It violently interrupts whatever journey the customer was on.
Okay, so it's too forceful.
Right. Then we have option C. The interaction is routed to the queue supervisor.
I feel like supervisors would hate that.
They would. If you think about how a call center works, this is a terrible operational practice. If the AI routed every single unmatched interaction directly to a supervisor, those managers would be completely overwhelmed with frontline calls in a matter of minutes.
Right, the entire management structure would just collapse.
Exactly.
Okay, let's unpack this. So by elimination, that leaves us with option D. The system reverts to the configured fallback routing method. This goes back to my airplane analogy, right?
Yeah, perfectly.
The AI is the trapeze artist doing the flips, trying to find the absolute perfect predictive match based on data. But standard queue routing, the fallback, is the safety net underneath.
That is exactly how the mechanism works, and why option D is the correct answer. The fallback mechanism ensures that if the predictive model times out, the interaction seamlessly drops into standard routing rules.
Oh, so the customer never even knows the AI tried and failed.
Right. They just get routed normally.
Love that. Okay, so if the fallback method is our safety net catching the users, the system still needs to know who it's catching. How does it identify the high-value VIPs from the, casual window shoppers?
That is the big question.
Right, and that leads us perfectly into evaluating our users with question 2. Question 2. Which factor is primarily evaluated by the system when determining if a visitor qualifies for a specific segment? The options are A, real-time digital behavior and device attributes. B, the historical average handle time of the agent they last spoke with. C, the total number of agents currently available in the assigned queue. D, the availability of a fallback routing method.
So this question is really testing if you know what segmentation actually means.
Right.
In Genesys predictive engagement, a segment is a category of users, like hesitant buyers or mobile users. Now look at options B, C, and D. They all share a massive fundamental flaw.
Well, let me look. Option B is agent handle time. Option C is available agents. Option D is fallback methods.
Notice a pattern.
Yeah, these are all about the call center. They're back-end operational metrics. They have absolutely nothing to do with the person sitting on their couch browsing the website.
Exactly. They're about the company, not the customer.
Mm-hmm.
You cannot segment a website visitor based on how fast an agent talked on the phone last week.
Right, that makes no sense.
Which leaves option A, real-time digital behavior and device attributes. This is the correct answer.
But how does that actually work mechanically? Like, what is real-time digital behavior?
It means the AI is literally watching the mouse cursor.
Wait, really?
Yeah, it's tracking scroll depth.
Mm-hmm.
It knows you are on an iPhone. It knows you've been hovering over the checkout button for 45 seconds without clicking. And it knows you visited the shipping returns page twice.
Oh, wow.
Yeah, that real-time data allows the system to instantly drop you into a segment called high intent but hesitant.
That makes total sense. Okay, so once we are safely routing and segmenting these users, how do we prove the AI is actually doing a better job than just standard routing?
You have to measure it.
Right. And just as importantly, how do we keep the AI from being incredibly annoying to the user? Let's look at question 3. Question 3. When running a comparison test for predictive routing, which two metrics are most critical for evaluating the performance of the predictive model against standard routing? Choose 2.
Oh, choose 2.
Yep. Here are the options. A, the improvement in the selected business outcome. B, the total number of action maps triggered per hour. C, the amount of time visitors spend on the company homepage. D, the reduction in transfer rates or handle time.
This question is a classic trap. It's really testing if you can distinguish between vanity metrics and actual performance metrics.
Well, let me guess here. Looking at these options, B seems really tempting. The total number of action maps triggered per hour. I mean, if the AI is busy triggering thousands of actions, isn't that proof that it's working better?
It's a common trap, but think about it from a business perspective. Just because the AI is throwing out thousands of pop-up coupons doesn't mean people are actually buying anything.
Oh, true.
Option B just tells you the engine is turned on. It doesn't tell you if it's effective. Now look at option C. The amount of time visitors spend on the company homepage.
That seems good though, right? More time on site.
Mechanically, this is highly ambiguous. Are they spending 5 minutes on the homepage because they are highly engaged? Or are they sitting there because the navigation menu is broken and they are hopelessly confused?
Oh, that is a great point. Yeah, more time does not equal a better experience. So B and C don't actually prove success.
Exactly. That means the correct answers are A and D. You evaluate the model based on option A, the improvement in the selected business outcome.
Hard data.
Right. Did sales conversions go up? Did customer satisfaction scores rise? And you pair that with option D, the reduction in transfer rates or handle time. This proves operational efficiency.
Makes sense.
If the AI routed the call so perfectly that the agent solved the problem in 2 minutes instead of 5 and didn't have to transfer the call to another department, the AI was successful.
So true performance is about the value generated, not just how busy the system is. Love that.
Exactly.
Now, before we hit the next question, let's quickly remind the listener what an action map actually is, since we just mentioned it. It's not a literal map, right?
No.
It's basically the AI's playbook for when to jump in and engage a customer on the website.
That's a great way to put it. It's a set of rules. Like, if the user does X, the system triggers Y, like popping up a web chat or a discount code.
Perfect. Which brings us to question 4. Question 4, why might a visitor who meets all the behavioral conditions for an action map not receive the associated content offer?
Okay, let's hear the options.
The options are A, the visitor has not yet been assigned a predictive routing skill. B, the agent handling the associated queue is currently on break. C, the frequency limits set for that specific action map have been reached. D, the outcome score is currently calculating the fallback method.
So this question requires us to separate routing logic from web engagement logic.
Okay, how so?
Well, option A talks about predictive routing skills, and option B talks about an agent being on break. Both of these mechanisms dictate how a phone call or a chat is routed to a human. But an action map is often just a static web content offer, like a pop-up guide. It doesn't necessarily need a human agent at all, so A and B are totally irrelevant here.
And option D, the outcome score is currently calculating the fallback method. I mean, that just sounds like technical word salad to me. An outcome score measures customer intent. It doesn't calculate fallback cues.
You nailed it. It's a distractor option designed to sound highly technical.
Sneaky.
Very. Which leaves us with option C. The frequency limits set for that specific action map have been reached. This is the correct answer.
I see this like the AI equivalent of an overeager salesperson in a retail store.
Oh, absolutely.
If you walk in and they ask you, can I help you every 30 seconds, you're going to get annoyed and just walk out. Sometimes the smartest action the AI can take is leaving the customer alone to prevent overexposure.
That's the exact mechanism at play. The system uses browser cookies and session data to track how many times this specific user has seen this specific pop-up. If the frequency limit is set to once per session, and they've already seen it, the AI intentionally suppresses the offer to maintain a non-intrusive user experience.
We've seen what these action maps can do, but, before a company even flips the switch on all these AI features, they usually have to justify the financial investment to the executives.
Always.
Let's look at question 5. Question 5. What is the primary purpose of running the benefit assessment tool before fully activating predictive routing?
Right.
The options are A, to automatically generate tracking snippets for the website, B, to estimate the potential return on investment and key performance indicator improvements, C, to forcefully disconnect idle interactions from the queue, D, to train the agents on how to read the customer journey icons.
Now, if you're taking this exam, question 5 is designed to trick you. They throw in option A, automatically generating tracking snippets.
Sounds very techy.
Yeah, it sounds incredibly technical and relevant to web tracking. But don't fall for it. Generating snippets is a basic deployment task for IT. It is not an assessment.
Okay, and option C, disconnecting idle interactions. That's just a queue management rule. And option D, training agents. Well, that's human resources and operations. None of those evaluate the potential of the AI system.
Exactly. So what does this tool actually do? It's option B, to estimate the potential return on investment and key performance indicator improvements.
How does it estimate that, though?
Mechanically, the benefit assessment tool ingests weeks or months of your company's historical routing data. It runs a simulation and says, hey, if you had predictive routing turned on last month, your handle times would have dropped by 12% and your sales would have gone up by 4%.
Oh, wow, so it proves it with math.
It allows leadership to mathematically justify the deployment before fully committing.
It essentially proved its own worth using the company's past data. That is incredibly clever. Okay, question 6 shifts us into real-time adjustments. Before I read it, let's just define outcome score. An outcome score is basically a live grade from 0 to 100 that the AI gives a user, predicting how likely they are to achieve a goal, like buying a product.
Right. Yep, spot on.
So, question 6. Beyond initiating a web chat, which 2 actions can be directly triggered by a configured action map when a visitor's outcome score drops?
Choose 2.
I'm going to choose 2.
Yep. The options are A, delivering a targeted web content offer, B, automatically upgrading the customer's subscription plan, C, initiating an advanced orchestration flow, D, resetting the predictive routing queue timeout.
Let's start with the most disastrous wrong answer here.
Please do.
Option B, automatically upgrading the customer's subscription plan. Mechanically, if an AI sees a customer's engagement score dropping, meaning they are losing interest or getting frustrated, and responds by automatically charging them more money for a higher tier subscription.
That would be illegal. At best, it's algorithmic pricing gone terribly wrong. You would lose thousands of customers in a day and they would be furious. Exactly. You never want the AI making unauthorized financial transactions based on a behavioral score.
No kidding.
Now look at option D, resetting the predictive routing queue timeout. This is purely an internal back-end routing function. It is not an action map response deployed to a web user.
Leaving us with A and C.
Correct. You can trigger option A, delivering a targeted web content offer.
Like what?
Well, mechanically, if the AI sees the outcome score plummeting because the user keeps abandoning their shopping cart, it instantly serves a 10% off discount code to win them back.
Ah, okay.
Or you can trigger option C, initiating an advanced orchestration flow.
Which means?
This means the system seamlessly kicks off a background process, maybe sending an urgent email to an account executive saying, hey, this VIP client is about to churn. Call them immediately. It orchestrates a save without tying up a random frontline agent.
That is so powerful. We've talked a lot about the automation side, but, eventually an interaction might reach an actual human agent. What do the humans see on their screens?
Yeah, the human element is crucial.
Question 7 asks exactly that. Question 7. When an interaction is routed to an agent, what information is uniquely provided by the predictive engagement journey panel compared to a standard interaction view?
Okay.
Options are A, a visual timeline of the web pages the customer visited before initiating contact. B, the exact script the agent must read during the opening greeting. C, the internal network address of the customer's internet service provider. D, the shift schedule of other agents in the same queue.
Think about what an agent actually needs to help a customer.
Right.
Option C, their internet service provider's internal network address is totally useless technical trivia. Knowing someone is on an AT&T routing hub doesn't help you process their return.
Definitely not.
And option D, the shift schedule of other agents, is workforce management data. It doesn't help with a live interaction either.
And what about option B, an exact script? I mean, I know some call centers use scripts, but that isn't unique to predictive engagement, right?
Right. Standard systems use scripts all the time, which makes option A the correct answer. A visual timeline of the web pages the customer visited before initiating contact.
Let me ask you this, though. From a consumer perspective, is it a little creepy for the agent to know exactly what web pages I was just looking at? Like, hi, Dave, I see you were staring at the red shoes for exactly 4 minutes.
It's a common concern.
Yeah.
But let's look at the alternative mechanism. The customer calls in. The agent asks, how can I help you today? The customer then has to explain, well, I was on your site looking at the red shoes, then I checked the sizing chart, then I tried to add them to my cart, but it threw an error code.
Yeah, that's exhausting.
That takes 2 minutes.
Yeah.
If the agent has that visual timeline, option A, they just look at the journey panel and say, hi, Dave, I see you were having trouble adding those red shoes to your cart. Let me force that through for you right now.
Oh, wow.
It's not creepy. It's deep context. It prevents the customer from having to repeat themselves.
That is a massive relief as a customer, actually.
Yeah.
Okay, question 8. We need to measure all of this. Question 8. Which report should an administrator review to analyze how often a specific web tracking event successfully led to a predefined business goal?
All right, what are the reports?
Options. A, agent adherence report. B, standard queue performance report. C, action map performance report. D, interaction quality evaluation summary.
This is all about matching the software tool to the business objective.
Okay.
The objective here is analyzing web tracking events against business goals. Option A, agent adherence tracks if human agents are taking their lunch breaks on time. Option B, standard queue performance tracks hold times and call abandon rates.
Call center stuff.
Yeah, exactly.
Yeah.
And option D, interaction quality, is when a manager listens to a recorded call and grades how polite the agent was.
Yeah, those are all call center operational metrics. None of them track web events. That leaves option C.
Exactly. Option C, actor map performance report. This is the correct answer.
How does it work? Mechanically, this report links the specific web trigger, like showing a promotional video, directly back to the predefined business goal, like a completed checkout. It gives administrators the mathematical proof of whether their web strategy is actually working.
All right, for our grand finale, we are looking under the hood at the brain itself.
The best part.
How does the AI actually learn to do all of this? Question 9. Which 2 historical data elements are essential for training a reliable predictive routing model? Choose 2.
Okay.
Options. A, the exact geographic coordinates of every customer. B, previous interactions successfully routed to specific agents. C, the color scheme of the customer-facing website. D, consistent and accurate wrap-up codes indicating the interaction result.
Well, we can eliminate the noise very quickly here.
Yeah, some of these seem silly. Very. Option A, exact geographic coordinates down to the latitude and longitude, is overly granular and mostly irrelevant to predicting skill-based routing. Option C, the color scheme of the website. I mean, whether your website is blue or orange has absolutely zero bearing on training a machine learning model for routing calls.
Right. So by elimination, it's B and D. But explain how this data actually trains the model.
Think of the machine learning AI like a brand new employee.
Okay.
Option B, previous interactions successfully routed to specific agents. This is the new employee watching a 20-year veteran do the job perfectly. The AI looks at millions of past calls and learns, whenever someone calls about a broken router, Agent Sarah resolves it fastest.
Well, that's really cool.
And then we have option D, consistent and accurate wrap-up codes indicating the interaction result.
How does that fit into the metaphor?
If option B is watching the veteran, option D is the manager grading the new employee's test at the end of the day. A wrap-up code is what the agent selects when they hang up, like sale closed or customer refunded.
Ah,
The AI needs those codes to know if the prediction it made actually resulted in a success or a failure.
I love that metaphor. That makes perfect sense. Okay, here is where it gets really incredible. Question 10.
Let's hear it.
Question 10. In the context of predicting customer behavior, how does the system dynamically adjust a visitor's outcome score during an active session?
Okay.
Options are A, by manually requiring the agent to input a score based on caller tone. B, by continuously analyzing real-time web activity against historical success patterns. C, by randomizing the score every 5 minutes to test different action maps. D, by copying the score from the previous visitor who used the same browser.
Let's shred the wrong answers by looking at the mechanisms here.
Yeah.
Option A is clunky and manual. I mean, a human agent cannot input a predictive score for a web visitor they aren't even talking to yet.
Obviously not.
Option C, randomizing the score every 5 minutes, completely defeats the purpose of artificial intelligence. That isn't predictive, it's just guessing.
Right, a total shot in the dark.
And option D, copying a score from a previous visitor is highly inaccurate because every visitor's intent is uniquely their own.
Leaving us with option B.
Yes. Option B, by continuously analyzing real-time web activity against historical success patterns. This is the correct answer.
Can you translate that into plain English? Like, what is it actually doing second by second?
Absolutely. Mechanically, the AI is watching your mouse click. It is comparing your single click to the last 10,000 people who clicked that exact same button and eventually bought something.
Wow.
And it recalculates your probability of buying, your outcome score, every single second, in milliseconds, based on those historical patterns. The score breathes, it adjusts live, click by click.
That is just wild to think about. Thank you so much for joining us for this deep dive. Keep questioning the systems around you. Best of luck with your continued learning and exam prep, and we will catch you next time.